Carolina A&T. This is our first HBCU-driven PI work, and we're very proud of this. And so I'd like to introduce Shalen Haper, who's a senior journalism and mass communication student with a concentration in public relations at North Carolina A&T State University, and Shanelle Clarke, a PhD student at Purdue University, who's pursuing a degree in aerospace engineering. Shalen and Shanelle, welcome to Imagine Aviation.
Hi, good afternoon, Steve. Thank you for having us.
Sure. I'll turn it over to you for your presentation.
Okay. Are you able to see my screen?
We are. Looks wonderful.
Okay, great. As Steve mentioned, my name is Shanelle Clarke. I am a PhD student in the Department of Aeronautics and Astronautics at Purdue University. And today I'm going to be presenting on the NASA Secured and Safe Assured Autonomy project, specifically in relation to secured autonomy for UAM operations. My chart looks pretty big here, but I'm going to break it down into quadrants and basically talk about what are our objectives with this project, where we are with respect to our current work, and where we see this project going. So specifically, we're looking at the urban air mobility system, which is the manned and unmanned air traffic system operating below the altitude of the traditional national airspace in and around urban areas. And we're working specifically in this project towards making progress in defining the vision for the UAM as a highly automated and cooperative air transportation system for various commercial and civil applications. And I know that we are all very familiar with the work that the private sector has been doing in designing personal air vehicles. These companies such as Amazon Air Prime for package delivery, Uber Elevate for air taxi service, and so on. But what we need to consider with the development of the UAM airspace is how to ensure safe, secure, and robust integration of autonomous aerial vehicles within the proposed concept of operations that NASA has outlined. And in doing so, we need to maintain compliance with any existing commercial and civil aviation transportation safety standards. And so with this in mind, with this objective in mind, we've mapped out what we call the technical challenges. And we've highlighted 4 high-level technical challenges. The first being safe perception, coordination, planning, and navigation. So here we're looking at how to develop a UAM architecture and technology that allows for flexible and adaptive coordination and control of UAVs, considering the level of heterogeneity with respect to the dynamics, the constraints, the environments that aerial vehicles are under, as well as, or employ, as well as the varying levels of autonomy between aerial vehicles and this operation within the highly dynamic and uncertain decentralized environment. And then the additional layer here is with autonomous aerial vehicles of varying levels of autonomy within a dense UAM architecture, we need to consider being robust or resilient to cyber attacks. And then putting these together, we need to talk about verification and validation, testing and evaluation of any proposed methodology. How do these work together cohesively and seamlessly? And then the 4th technical content is with respect to system integration. So adding this verification and validation and properly integrating it into the simulation and the physical environment. Particularly, I'm concerned with the work in secured autonomy, technical content too. And so within the work of secured autonomy, we're specifically looking at modeling the UAM system as a cyber physical system. That is, I'm going to concentrate on this diagram right here, is how do we model the physical, logical behaviors of autonomous aerial vehicles within the UAM We need to model the communication network, the sensing capabilities, and being able to integrate that into an explicit mathematical model of the UAM from a CPS perspective. And then given that we have varying levels of autonomy, heterogeneity across aerial vehicles, we need to be able to analyze different types of cyber attacks according to different levels of severity, and our abilities to detect and identify when a cyber attack is happening, so that we are able to improve the resilience of our system. And so within secured autonomy, an additional challenge here is with respect to current work within the literature or even what's being implemented in industry, we realize that there's a room for development of a lightweight and efficient intrusion detection system, possibly using state-of-the-art artificial intelligence paradigms to be able to address different UAM cyber attacks. And then we kind of put this all together and test the algorithms that we've developed here within a unified framework that benchmarks the resilience of the control strategies, or the from a cyber-physical perspective, from a cybersecurity perspective. How do we need to benchmark the resilience of these developed algorithms to varying severities of malicious cyber attacks within a fully distributed UAM scenario. And within this technical challenge, TC2, our success metric comes with developing algorithms and control methodologies that utilize less than 10% of our overall system load, but also are resilient to varying categories of severity of cyber attacks. And we have different levels, and the most severe one would be a level 5 cyber attack. And so we want to do all of these things, but how are we currently achieving them? So within TC2 itself, and I know these are a lot of words and it's kind of small here, but what I want to highlight is that we've divided up these barriers and challenges into objectives. And so the first objective would be modeling, a mathematical modeling from a CPS perspective of the UAM and different cyber attacks. The second one being looking at, the second objective is concerned with analysis of cyber attacks and detection and risk management of those. The third objective is essentially developing this AI-driven cyber attack monitoring IDS system. And then the fourth one would be looking at developing some type of system that allows us to construct a resiliency benchmark for the fully distributed UAM scenario. And so we have a lot of students working on this across different universities. And I've given you this Venn diagram to show you that a lot of the work is overlapping as we try to tackle not only the work within our respective areas that we've designated ourselves, but also we collaborate and help each other out to achieve other objectives. And so this is my work on cybersecurity for secured autonomy in the UAM. And now I want to turn over the presentation to my colleague Shalen, who will be talking about considerations on ethics and social responsibility that we need to take into account as we perform this work. So I'm just gonna zoom out here and then let Shalen go ahead.
All right, thank you so much, Shanelle, for that introduction into my project. Welcome, everyone. I'd like to take you on a quick lesson through ethics and social responsibility today. Understanding laws and ethics and being able to communicate with the target audience is essential for any field. This is especially essential for students within the STEM field because they're the ones building the two tools of the future. So every message that they convey should be carefully crafted to accomplish a specific purpose or business goal. And our research goal was to broaden students' understanding of today's highly interconnected, technology-driven, and complex global business environment. We also wanted to break the traditional silo mentality, and we do this through encouraging interdisciplinary studies and discussion. So my presentation is going to explore ethical practices in business, communication, social media, and the interplay between machines and humans. Using case studies, we've used it for workshops and presentations, and for students measuring in STEM. So for the first part, I'd like to introduce you to our social media ethical section. Scroll up just a little bit more.
Okay.
All right. The first box, comparison tweets case study. We compared two social media posts, one from Justine Sacco in 2013, where she tweeted, right before boarding a plane, going to Africa, hope I don't get AIDS. Just kidding, I'm white. Before the plane even landed, her employer responded saying that she was fired, also sent out their own tweet. Compared that to Taylor Swift, who in 2015 managed to change the senior vice president of Apple's mind and have them change the company policy on Apple Music royalties. When she tweeted, "To Apple, love Taylor. We don't ask you for free iPhones. Please do not ask us to provide you with our music for no compensation." Zoom out just a bit for me.
Unfortunately, that's not something that PowerPoint lets me do. I can zoom out all the way.
Okay, that's good, actually. So to foster and generate conversation during each of our workshops and presentations, we ask students different questions and they ask us questions back. The question that I chose to highlight for this section, why did Taylor Swift cause change when Justine Sacco was fired? Our next section was on moral and legal implications. So Forest Laboratories and Celexa, which is their drug, in 2010, Forest Laboratories was pled guilty to promoting Celexa off-label and bribing doctors into using it for something that it wasn't supposed to be used for. Now, they did generate $1.4 billion in revenue, but as far as their settlement, they had to pay $313 million in settlement. They had to let any healthcare providers know that they pled guilty to unethical practices, and they also had to do annual reviews with the Department of Health and Human Services for the next 5 years. So the question we asked students was, comparing the profit to the punishment, do you think Forest Labs lost more in the long run? And ethics is a common theme throughout this presentation. So my next section is on ethics and autonomy. That box right there, one of them is the MES robot, and you'll see children in that picture. The MES is an actual robot, and it's used to help children learn things. It blinks, it moves its head, it makes noises, and has emotions. The gray version of that robot is the MES that was used for a case study and experimentation. The robot was pretty much turned into a personal assistant, kind of like a moving, breathing Cortana, Siri, Alexa, whatever you use. And the purpose of the robot was to sit in the homes of 3 different people with different attachment styles for 10 days, and they thought that they were supposed to just teach the MES a color because it learns based on repeated exposure. But in actuality, the goal of the presentation and the project was to measure the emotions of the robot. The robot stayed emotionally consistent and stable throughout each part. So we asked students, how could the varying emotions of the MES conflict with Asimov's laws of robotics? And during our workshops and presentations, we taught students about Isaac Asimov's laws of robotics and corporate social responsibility. Speaking of CSR, that brings me to my Nike case study. From 1992 to 2005, Nike was involved in a greenwashing scandal. So at first, Nike's presentation was Nike's company, was accused of indecent practices in Indonesia. They profusely apologized and promised to be committed to their workers. However, about 5 years later, Nike was once again revealed to have indecent practices in a Vietnam factory where workers were working 65 hours a week, less than living wage, and 3 out of 4 workers ended up with respiratory illnesses. Because of this, Nike was sued in 2001, sued in 2003 for false advertising. This battle goes on for 2-3 years, with eventually Nike losing this CSR. And the question we asked students was, if Nike's factory conditions do not break laws, should the public be more forgiving in its stance against the company? Why or why not? For our next steps, we're thinking about exploring human decision-making in machines versus people. But for more information on that, you'll have to stay tuned. Thank you so much.
Great. Thank you so much, both of you. There is a couple questions out here, and we have a few minutes. I'll get them thrown out there. It's really interesting work. One of the questions is, many of the technical challenges that your team is taking on, they're really not routinely taught in traditional aero engineering curriculums. So what backgrounds of your team members have you noticed really have added and brought to solving some of these problems and creating solutions?
Okay, yeah. That is exactly right. A lot of these technical challenges, students aren't necessarily, are not equipped by a traditional education to tackle them. And so what I've noticed across the universities, we've employed a wide range of talents to be able to attack these challenges. So for example, we have, my background is in adaptive and optimal control with some, with also some work in cybersecurity. We have some people working in UAV system integration, working in the labs. There's some people working in perception. And so we've kind of trying to unite all of these areas into tackling each of these technical challenges that we've outlined.
So one of the technical challenges that I know comes up, and it was in the IO chat, that either jamming or GPS spoofing, it's that bane of all of RF communications. Do you have any solutions for these kind of attacks yet? Have you looked at anything? Is something promising to you on this front?
Actually, yes. So specifically within TC2, Professor Mahmood's group out in NCAT actually is working on AI-driven cybersecurity monitoring. And so the project that I have here is backdoor Trojan attacks, but previously in the last year, they have worked on identification of GPS spoofing attacks using supervised machine learning. So, and there was a paper published on that work at a conference. So we have been looking at different types of cyber attacks that may impact our system, the proposed UAM system.
Nice. Have you looked at any blockchain or distributed trust systems as a means for multiple aircraft to communicate with each other?
So I know that in the literature, there's significant research going on with respect to blockchain technology and how that can be used within the proposed UAM system and looking at different cyber attacks. We do not currently have a project that's specifically looking at that, but it is very interesting, and I think a direction for future consideration as the project goes on. Sure,
absolutely. Tell me, Shalen, tell me your experience in working with other universities, not just where you attend, but other universities and partners in the private sector. What's that been like in this effort?
So we have quite a few partners, and if you go to my slides, you can see some of them. And Shanelle works with our school, but also Purdue. So it's been really interesting, just like being able to see all that they bring to the table and the different and new ideas, because we're an HBCU, so we tend to look at things a little bit differently than maybe a PWI would. So it's been really cool and just really fascinating to see all the ideas brought to the table.
That's great. Shanelle, same question. As you explore and interact with different universities that you might not have outside of this effort, what's that been like?
It's been interesting, especially within the last 2 years of COVID, because most of our work has been virtual. So a lot of the collaboration efforts where you might go from one university to another, a lot of that has been restricted. And so I've been doing a lot of Zoom chats, trying to figure out each other's work styles, and trying to collaborate across universities virtually. So that has been definitely a lesson there. Also, with respect to industry partners, they have been taking a very active role in participating with the different TC groups. So I'm very happy about that, and they've been very welcoming to all the students and engaging with all of us. So it's been good, pretty good so far.
Oh, that's great. It's very exciting to hear this, and it's very exciting to hear all the presentations we've heard today. So I do want to thank you, Shalen and Shanelle, for a wonderful conversation. Thank you so much for your presentation on your work here today.
Okay, thank you very much, Steve.
Happy to be here.
Great. We just heard about 3 very interesting efforts from our University Leadership Initiative program, and how the work of these students in the university is paving the way for not only future technological breakthroughs in aviation, but has allowed us to meet some of the great emerging thought leaders of tomorrow in this field. We want to continue that conversation today with a panel discussion, and it's with some of these students regarding a topic